Hi everyone. This is team two. So we're about to do our final project presentation. My name is Yuehua, and this is my teammate Charu. And our topic is about the COVID-19 monitor system. So let's get started. So first, this is the list of content that we'll be going over. So first is the objective. That's what we did for this project. Then the design architecture will be the architecture that we implement in this project. And then after that is the ERD, which is an entity relationship diagram. And that includes the table and all the documents that we use in the project and what information is contained in each table. And then there will be the data implementations. There will be what we did before importing the datasets and what we did to the datasets and how we import them into the ArangoDB, which is the data management system that we use. And lastly is going to be the visualizations that we did in this project. So first, objective. So first we need to collect data first. So for this project, which is mainly collecting COVID-19 related data, they from different countries, they from different states, that contains different informations. More detail will be going over in the ERD slides. And then we use ArangoDB, which is how we store the document collections and access informations. And then we'll analyze those stored informations and the data to answer the question we might have later on. And then lastly, we can do visualizations using the Power BI with graphs to identify the trends and patterns to help us evaluate and compare the daily growth of COVID-19 cases in different scenario to understand the COVID-19 trending better. Then is the design architecture. So first we find our data sources online using Google search to search the relative informations. And then the data ETL, we just use Python, so coding languages. And we use Jupyter Notebook to extract, transform, and load those informations. And then we use a tool to load the data sets into ArangoDB, which is where the data stores. And then after the collection has been created and stored, we can use the Power BI to interact with ArangoDB and write queries to do the visualizations to understand the data information better. Then this is the ERD diagram. We have 5 tables, which is 5 collections. So most of them sharing the same keys and informations. So you can see like from the tables here, it has a lot of them has like locations and iOS code, which is the code for the locations. So for like states, it contains the state's ID, locations and the vaccination in that state, or the people vaccinated, or the people fully vaccinated, which is like the people who got 3 doses of vaccinations. Or the country, they have the country code and the country ID and the source name, which just tells you, what kind of vaccinations they have in that code in that place in that country. And COVID test, which the test ID contains the location as well. It has the date and it has the total tests, like the number of tests that they have been doing in that place. And for the populations, it also tells you the populations, the population in that country, and the age 65, age 70, so on and so forth. So that's the ERD diagram that we have. Then data implementations, because we use different data sources from different websites. So we use Google Colab to do this data pre-processing. And the code right here shows just part of it. I didn't really include all of the code because due to the size. So we use this sort of Google Colab to import the CSV files that we have it from online. Then we do some pre-processing, things like adding indexes, creating columns, extracting data and the transfer informations or drop duplicates, things like that. And we generate CSV file and we convert to JSON file to ArangoDB import. And how we import into the ArangoDB, just pretty simple, like how we did in assignments. We use the ArangoDB import. We use the command prompt to enter those information, enter the file, enter the address. Then we create those collections in the ArangoDB so that we can use for later on. And for ongoing data refresh implementations, that's like one of the code that we using references because from the modules that provide it. And because there's isn't a lot of tool online to do this kind of thing, so we just mainly use the code. And this is part of the code, and I will show a live demo real quick. So this is what we use for this ongoing data refresh. I will go over this kind of code real quick and just tell you what it means and what it does. So mainly this part just connect the ArangoDB with our client because you want to initialize the client and for ArangoDB, and you connect the database of the root users, and you want to initialize the path for the file that we use, which is the datasets we have. And this line just tells you what kind of file contained in this path. And this function is just pretty much getting the modification times because later on we're gonna use it to detect if any changes made to file. So we'll returns to you the modification time in a local time, and of course I'll transfer it here. And this was the main part. It's gonna call the function 2 times, and it's gonna detect it and gonna compare. And I add some code to do like a command so that it will run every time when I enter some command. So it will suspend, this one just tells you, it will suspend the execution for every 2 seconds. And it's gonna call the function and compare the information contained in each file. So if there's any changes has been made, if it's no changes have been made, it will be passing. But if it's any changes have been made, then that will trigger this part and we'll just load those JSON file again back to the ArangoDB. So before that, I want to say, what the ArangoDB contains, what information contains. So this is ArangoDB, and this is the country, and this is one of the what it looks like. And this is also the file we have for country, and it has those information. They are the same, the locations, the country ID, the ISO code, the vaccines, Moderna. That's what it looks like. So before I do anything, I will just show you guys what it looks like. So if I change this vaccine from Moderna to say something like no, and I save it, and from here, and it pops up say if you want to do if you want to detect or not. So if I enter C, that will just create the user and detect if any changes have been made. So it's gonna tell you, oh, right here, country is updated. So new information will be loaded into the ArangoDB. So if I refresh this page right here in ArangoDB, you can see that vaccine has been changed. So that's how those ongoing data refresh has been doing. And for the presentation purpose, that's what I do for this kind of command prompt. And if I enter Q, it's gonna quit the code. So pretty much that's how we implement this sort of ongoing data refresh with ArangoDB. And later on, it's gonna be the data visualizations my teammate's gonna be doing.
So for data visualization, we have used the Power BI web connector to connect ArangoDB to Power BI and create graphs and reports. For the first graph, here we have total cases by continents. So here we can see we have used an AQL query to generate the data and visualize it in Power BI. So first it shows according to continents, and then it sorts according to countries, and it shows the total number of cases occurred in either a country or a continent. Next, please. The next slide here, we are using our states data set to find out the people vaccinated in each state. And we also have the AQL query down here, and we can see the cases, the vaccinated people for all the states in the United States. This graph here shows us the total vaccinations and the booster shots that people have taken all over the world. And it sorts it here. We can see even when the countries have a high total vaccination count, they still have a low booster count. So here we can compare if a country has a booster count or it has a total vaccination count and compare them. Here we have used a map, a filled map, and we are showing the total cases and the positivity rate. So the dot size shows the total cases, and the saturation of the color over each dot shows the positivity rate all over the world. So these are the various visualizations we used, and that's all for team 2.